Hello everyone, this is Zagyapan from the Electrical Electronics Engineering Department in Bilkent University. Today I will be presenting my project on investigating the correlation between a counterweight's mass and the initial velocity of a payload. So the aim of the experiment is to explore how the mass of a counterweight in a trebuchet impacts the initial velocity of a payload launched by it. I adjusted the counterweight's mass m and I measured how far the payload travels, which is the horizontal displacement r, how high the payload is from the ground the moment it starts its motion, which is the magnitude of vertical displacement h, and how long it stays in the air, which is the time t. From these values, I calculated the initial velocity v0 using the principles of projectile motion. So we have our catapult here. This is the mainframe. This is the arm that is going to throw the payload. This is the cylindrical pin that is holding the arm. This cup will be our counterweight, and this ball will be our payload. So we have 5 sets of bolts here, and each one of the bolts weigh 15 grams. And this cup already weighs 9 grams, so this will be put into account. And in every set, we will add 75 grams to the counterweight. So now we can start with our first set. As an example, I will show you the second trial. So we have 10 bolts here, and I will hold the catapult parallel to the ground as the vertical displacement should not change. And I will throw the ball. And I will put a stick to roughly estimate the place it lands. After collecting the data seen on the screen from the trials, I calculated the initial velocity using this data with the following equation. And after calculating the initial velocities on the screen, I drew the graph of initial velocity of the payload versus the mass of the counterweight. The graph and the values demonstrated a positive linear correlation between the counterweight mass and the initial velocity of the payload. I didn't have a fixed value that I could compare my results with to find an error, so I took the uncertainties of the video recorder and the measuring tape I used in order to calculate an error margin using the following error propagation formula. Using this formula, I calculated the error margins seen on the screen. And when I took the average of these values, my average error margin turns out to be 0.101 meters per second. So this error margin could have been caused by several factors, including measurement errors such as the human reaction time while starting and stopping a timer, systematic errors such as the neglected friction and air resistance, and the uncertainties of the measuring tools I used.